Section 6.4 is on page 437. It talks about binomial coefficient and identities. We're interested in this coefficient for later on chapters. So if I take x plus y cubed, if you multiply those, FOIL the first two, distribute into the third, you end up with such an expression. But the part that's really not showing, and I want to make sure that you see that, the way it works when you expand those, you get the first to that power, and then you reduce it by 1 power, and then you reduce it by another 1 power, and then you could think of it as to the 0 power if you like. The deal is each of those terms must have that power. So if this is x cubed, that's a 3. If this is x squared, that means the y, the positive y, picks up the 1 because the powers must add up to 3. If you have x to the 1 power, that means the y picks up the 2. And if you have x to the 0 power, that means y picks up the 3. So if you really glance at this, the variable part is x cubed, x squared y, xy squared, and of course y cubed. So x runs from 3 to 1 and 0, and y runs from 0, 1, 2, and 3. The tough part is not those. We always could figure out what these are. That's really easy. The tough part is the coefficients. That turns out to be the troublemaker. And in this case right here, this happened to be a 1, this happened to be a 3, this happened to be a 3, and this happened to be a 1. So the first person to figure out how this works was Pascal. And Pascal figured out if you take a plus b raised to the n. So for example, if I take x plus y raised to the 4th power, I know the coefficients will be x to the 4, the variables will be the first to that power, then x cubed, that means the y will pick up the 1, then x squared, that means y will be squared because those must always add up to 4, then x to the 1, that means y picks up the 3, and no x or x to the 0, y pick up the 4. The issue was always the coefficients. Pascal figured out if you take a plus b to the 0 power, that's a 1. If you take a plus b to the 1 power, the coefficients would be a plus b, a 1 and a 1. That's these coefficients. If you take a plus b and you square it, that's a squared plus 2ab plus b squared. And the coefficients are a 1, a 2, and a 1. If you take a plus b cubed, you know that's a cubed plus a squared b plus ab squared plus b cubed. The coefficients are listed right there. Pascal figured this out a long time ago. Now, how did he get these numbers? I'll show you in a minute. And if you take a plus b to the 4th, which is what I have up there, then Pascal figured the coefficients of a plus b to the 4th is a 1, a 4, a 6, a 4, and a 1. And that would be the answer. And how did he figure this out? Well, his condition was he figured this out very easily. This is what he did. He said start with Pascal's triangle, a pyramid. List a 1, then a 1 and a 1, add those two, you get a 2. Add those two, you get a 3. Add those two, you get a 3. If you add those two, that's a 4, a 6, and a 4. A 5, you add those, you get a 10, a 10. So he figured out how all of these coefficients work. So a plus b to the 5th will have a 1, 5, 10, 10, 5, 1. And that's how you figure all of these out. So this was for the longest time. And then the binomial theorem came along. The reason this was, or let's put it this way. The limitation of Pascal's triangle was if you want to figure out what a plus b to the 60th you need to list Pascal's triangle for 61 of those rows to figure out what these coefficients are. And remember, we're not interested in the whole thing. We just want a single term for our study. Now, binomial theorem comes up and they figure out a different way of doing this. They say if you take x plus y to the n, they say, look, that's x to the n minus 1, x to the n minus 2, minus 3, all the way to x to the 1 and no x. And this has no y. This picks up y to the 1, y squared, all the way y to the n minus 1, y to the n. The coefficients that Pascal figured out, they said this is NCR0, this is NCR1, this is NCRN minus 1, and this is NCRN, and that's how you find all of these coefficients. So if I wanted to use a plus b, x plus y to the fifth, this is on page 443. So one way of doing this is for me to say, you know what, this is going to be x to the fifth, x to the fourth y, x cubed y squared, x squared y cubed, x y to the fourth, y to the fifth. Now, the coefficients, I'm going to do this two ways, so let me copy this. Of course, the binomial theorem has a massive advantage if you just want to know one term. So if I want to use the binomial theorem, that's really saying this is 5 NCR0, this is 5 NCR1, 5 NCR2, 5 NCR3, 5 NCR4, and 5 NCR5. Or they're simply saying, if you really think about it, they're saying this is 5 factorial over 0 factorial and 5 minus 0 factorial. This is 5 factorial over 1 factorial, and 5 minus 1 factorial is 4 factorial. And after a point, this is 5 factorial over 2 factorial, and 5 minus 2 factorial is 3 factorial. 5 factorial over 3 factorial, and 5 minus 3 is 2 factorial. And 5 factorial over 4 factorial, and 5 minus 4 is 1 factorial. And 5 factorial over 5 factorial, 5 minus 5 is 0. Remember, 0 factorial is 1. And what do you notice? Do you notice that this is always the power? And do you notice that since multiplication is commutative, you're not going to miss out on any of this. And that's like 5, and there's an x to the 0 power. So it's very easy to figure out what a specific term has a coefficient of. You just remember it's n factorial over this power factorial and this power factorial, and that works. And that's the beauty of this. Now, if I want to use Pascal's triangle, all what I do, I go to a plus b to the fifth. 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. So my answer would be right there. Now, if I take my calculator, these cancel out, that's a 1. This is 5 times 4 factorial, the first cancel out, that's a 5. This is 5 times 4 times 3 factorial, the 3 factorials cancel out, 2 divides 4 2 times, 5 times 2 is 10. The same deal here, this is a 5 and this is a 1. So factorial is a lot messier, but if I just want to find specific term in, say, x plus y to the 50th power, then Pascal will be very challenging to do because I need to list 51 of those rows in Pascal's triangle. But if I follow such as number 4, for example, so if I just want to know what the coefficient of x plus y to the 13 is, so I know if you have x to the 5th y to the 8. You see those add up to 13? I know, instead of listing Pascal's triangle, and I have to go 14 rows, which is a lot of work. So that's 0, x plus y to the 1, x plus y squared, x plus y cubed. All what I have to do is say that's 13 factorial over 5 factorial, 8 factorial. So the coefficient is right there. And you could leave it like that on a test. You could plug it in your calculator like we did. Remember, it's NCR. So you could say 13 NCR. 8 or 5 will give you the same result, 1,280. 87, isn't it? 7, correct. That's the coefficient. That's all they want. And if I'm looking at 1 plus x to the 11, again, instead of listing 12 of those, well, I know you're going to have a 1 and an x. The power must add up to 11. If they want x to the 7, that means this must be raised to the 4th power. Find the coefficient. The coefficient of this will be 11 factorial divided by 4 factorial, 7 factorial. So you could leave it like that on a test, or you could plug it in a calculator if you wish. 11 NCR, either 4 or 7 will give you the same result. Let me just make sure you understand that. 11 NCR 7, 330, regardless. So that's why Pascal's triangle is limited, but the binomial theorem is extremely useful to find specific terms, especially when the power is really high. But expanding something, to the 5th to the 4th power, I think Pascal is just as easy. How about this problem? What is the coefficient? If they want x to the 8, and if they want x to the 8, that's what I want to write, and y to the 9. Well, let's see. X, it's really 3x, and y, it's really 2y. So you take the whole term. What's taking the place of x in the top equation is 3x. What's taking the place of the y is 2y. So the coefficient up front, they want just the coefficient, but in front of this is 17 factorial divided by 8 factorial, 9 factorial. So the coefficient of all of this mess, if you really think about it, is really 17 factorial, 8 factorial, 9 factorial, times 3 to the 8 times 2 to the 9th. That's the coefficient. On a test, you could leave it like that. For the homework, you get your calculator, you take 17, choose 8 or 9 makes no difference. I already showed you that's the same thing. That's with the C. With the P, it does make a difference. I'm going to multiply that by 3 raised to the 8, and I'm going to multiply that by 2 raised to the 9, so it's a massive number. I'd rather you leave it like this, but the back of the book will most likely has something like this. So it doesn't matter to me which way you leave it in. And here they say use the binomial theorem to expand. Now look, notice they made it a minus, so you have just to modify it a bit. You have to say it's 3x plus a negative y squared to the 4th. So if they say use binomial theorem, okay, I could use Pascal. I really don't mind what you use. Either way, if it's the 4th power, use whatever you like. So you could use the binomial theorem and say, okay, you know what? That is 3x raised to the 4th and 3x raised to the 3rd. That means the negative y that means the negative y squared is raised to the 1, the 3x squared, the negative y squared squared, the 3x to the 1, the negative y squared cubed, and no 3x, just negative y squared raised to the 4th. Now the coefficients, if you want to go ahead and say that's 0, 1, 2, 3, and 4, that's a 1, 4, 6, 6, and a 1, or if you want to say this is 4 factorial divided by 0 factorial, 4 factorial 0 factorial, you want to say this is 4 factorial divided by 3 factorial 1 factorial, this is 4 factorial divided by 2 factorial 2 factorial, this is well, this is just a 1. This is 4 times 3 factorial. Those cancel out. You're left with a 4. This is 4 times 3 times 2 factorial. 4 divided by 2 is 2. 2 times 3 is a 6. That should be a 4 right there. I messed up on that one. And again, you could use whatever you like. It's up to you. I don't mind. Again, even though it says use binomial. And you're going to say that is, notice there's a 3 in there, right? So this is going to be 3 to the 4th, 81x to the 4th. It's going to be a minus in this case. 3 cubed is 27. 27 times 4, I'm really horrible with math. 3 to the 3rd is 27 multiplied by 4. That's 108. Plus, because you can 9 times 54 x squared y squared minus 3 times 4 is 12 xy to the 6 plus y to the 8. So there it is. On a test, I have no problem with you leaving it just like this or with these coefficients. I can care less. To me, all of these mean the same thing. And let's look at what they want. They want specific terms here. Let's look at part A. They want to know, can you tell me which term has x to the 6, y to the 9? Well, think about it. Use binomial theorem to find just the coefficient. So if x to the 6, y to the 9, wouldn't that mean the coefficient is 6 factorial? Now, what do you raise to the 6th power to get x to the 6? I have 5x squared. Start this way always, the terms first. What do you raise x squared to get x to the 6? Isn't that a 3? And what do you raise, well, if this is a 3 and the whole power is a 6, isn't that a 3 automatically? And if you think about it, this is 3 factorial, 3 factorial. So when they say in part A, what's the coefficient, you would say that is, either you tell me it is 6 choose 3, which is fine, times 5 to the 3rd times 2 to the 3rd, or you multiply that out in your calculator. Or you leave like that, times 5 to the 3rd times 2 to the 3rd, whatever makes you happy. If I go for the second piece, B, if they want a squared b to the 15, well, let's see. There's no a. X to the 2nd power, y to the b, y to the 15. Well, again, I have no control over. The first term is always going to be 5x squared. And the last term is going to always be 2y cubed in this expansion. No choice. To get an x squared, don't you put a 1 there? That's the only way to get an x squared. If this is 1, isn't this 14? So for part B, I know the coefficient is 15. Choose 1 or 14 gives you the same answer. Right? Or you could say it's 15 factorial over 1 factorial 14 factorial, or 14 factorial 1 factorial. Either choose 1 or choose 14 has the same result, but it's going to be 5 to the 1 times 2 to the 14. That will be the coefficient for part B. If I go for part C, they want to know, how can you get an x cubed and a y to the 12? Again, 5x squared and 2y cubed. If I want to get x to the 3rd power, the only way I can get that, that's a 2. So oh boy. Give me 1 second. Since we're dealing with integers, there's no way that could happen, because the only way I can get y to the 12, that's a 4. And if that's a 4, that's automatically a 2. So that will be x to the 4th. So the coefficient will be 0, meaning there's no such term. So C will be 0. Because you could have 0 times that if you wish. How about D? If A is 12, if A is 12 and Y is 0, well, let's see. That means the 5x squared must be raised to the 6 and the 2y cubed must be raised to the 0 power. That works. And the coefficient will be, of course, 6. Wait, where did 15 come from? That should be 6 factorial. Oh boy, 6 choose. The highest is a 6. So that's going to be 6 factorial divided by 6 factorial 0 factorial. Well, that's really a 1. So you could write a 1 times 5 to the 6th power. 2y to the 0, you could write it, but that's just a 1. And if you go for E, this is D. In part E, they want us to find x to the 8, y to the 9. Well, to get this to the 9, that has to be a 3, which means the 5x squared must be raised to the 3 power. That gives you 5 to the 6. No such number, you put a 0 instead. And that's how you do all of these. Now, I need to show you a couple of things for the graph theory that's coming up in chapter 9. So this is the binomial expansion. The formula is right there. So you start with x to the, when j equals 0, that's x to the n, y to the 0, and it picks up. Notice, if I take x plus y to the n, and I put 1 plus 1 to the n, 1 plus 1 to the n, according to this theorem, actually let me do that on this side, that's why I saved some space. So if I take this, and I put a 1 plus 1 to the n, that is the series j equals 0 to infinity, 0 to n of n choose j, 1 to the n minus j, 1 to the j. But isn't that just a 1? And what's that? 1 plus 1. Isn't 1 plus 1 2 to the n? So they replace j by k. No big deal. There it is. This second property that I need for later on, they have a negative 1. If I take a 1 plus, or a negative 1 plus 1 to the n, that will be the series j equals 0 to I'm so stuck on infinity, of n choose j of negative 1 to the n minus, let me just think about that, n minus j, okay, actually let's go the other way around, 1 plus a negative 1, that will be 1 raised to the n minus j times negative 1 to the j. So wouldn't this really mean the series j equals 0 to infinity? Oh man, infinity, I'm so stuck in the series from calculus. And choose j. Isn't 1 raised to any power 1? Negative 1 to the j. But isn't 1 plus 1 0? So there it is. And if I take 2, or 1 plus 2, if I want to go in that order to the n, that's the series j equals 0 to n, and choose j of 1 to the n minus j times 2 to the j. So I'll get 3 to the n equals series j equals 0 to n of n choose j. 1 to any power is 1 times 2 to the j. Again, they just replace j by k, and that's the same thing. And that's pretty much it for this section.